Hey everyone, welcome to today's session. We are going to go through items that appeared in mocks about linear programming, explained step by step. And linear programming is just a method used to find the best way of doing something when you have limited resources. For example, a farmer may want to maximize the profit or minimize the costs, but is restricted by money, land, and number of animals. So that is all about linear programming. And this lesson is very good for students from senior 2 up to senior 6, and even some teachers. This video will help you explore more about linear programming. If you have not subscribed to our channel, make sure that you like, subscribe, and share. So what do you need to know about linear programming? What are the components of linear programming? Number one, we have decision variables. In decision variables, you have to learn how to define those decision variables very well. And when you are defining your variables, we don't use other variables other than x and y. But in other parts of patterns and algebra, you can use other variables. But here in linear programming, we are limited to only two variables, that is x and y. Then there is what we call constraints, all inequalities, all conditions, even we can say limitations. Whenever they talk of constraints, the same as inequalities, at the same time conditions. But you can see in some scenarios you find when they are asking to find the mathematical statements that show the relationship between the two things talked about in the scenario. So still, those are also inequalities or constraints. Then we have data, the information given, and then we have also the objective functions. For the case of objective function, it's also called an optimization function. And when we are writing an objective function, it is always written in this form. It can be cost or profit. So for the case, so it should be in this form of ax plus by. Now, in most cases, what challenges most students are the inequality symbols. Most of us don't know when to use less than, when to use greater than, when to use less than or equal to, and greater than or equal to. So in this video, you are going to master them very well. And here are some of the inequality symbols, and you are going to go through them. The word less than, you can see the symbol is there. We have also greater than, we have less than, all equal to, and even greater than, all equal to. And I may ask you, if at all I tell you to send me less than 5 learners, there is no way how you can bring 5. Even we can use some other words like fewer than, lower than, smaller than, shorter than, and below. The moment they say that whoever scored below 50%, then just know that we want those who scored less than 50%. Then also we have greater than, which is same as more than, exceeds, larger than, longer than, and even above. All those words can be used instead of greater than. Then also we have less than or equal to. The word less than is same as at most, the maximum. The moment I say that I want a maximum of 5 boys, so there is no way how you can send me 6 boys. You have to send me 5 and below. So that is the word maximum or at most. So that whenever you see the word at most, just know that they want the maximum or not more than that value that you have been given in the scenario. So for the case of less than or equal to, let's always go for when do we use it? After seeing the word at most, even maximum, not more than, not greater than, does not exceed, not above. All these words just mean at most, less than or equal to, all the maximum. Then we have also greater than or equal to. We always use it when we see the word at least. The word least means the smallest value. That's why you are seeing me here having minimum. So whenever we are talking of greater than or equal to, if at all I say that I want at least 5 cows on my farm, then just know that I want a minimum number of cows as 9. So we may need from 9 and above. So that is the word minimum. It doesn't go below that. So here we can use words like not less than, not fewer than, not below, not smaller than. Even you can find other words that you can use to mean greater than or equal to. And in most cases, I may come here like less than or equal to, and I ask you, assume you have been given pocket money of 50,000 shillings to buy pocket money to push you maybe up to visitation day. But when you are to buy things at the canteen, you cannot buy things of more than that money. You cannot spend more than what you don't have. Instead, you'll spend the whole 50k and below. Then one of the things that you need to know when it comes to graphing. Now, for the lines, for the inequality symbols less than and greater than, the boundary lines are always dotted or broken. And for the inequality symbols greater than or equal to, or less than or equal to, the inequality symbol is the boundary line is drawn bold or solid. So make sure that you master there. As long as you have used an inequality symbol of less than or greater than, then the boundary line should be dotted or broken. But for the case of these two inequalities, greater than or equal to and less than or equal to, then the boundary line should be solid or bold. And when we are graphing those inequalities, we do shade the unwanted region, and we label those lines as equations, not inequalities. Never come to you, the Cartesian plane, after drawing showing an inequality on a Cartesian plane, and then you label that line as an inequality. No, you'll be wrong. Instead, always label it as an equation. Then we have that region that remains unshaded after shading a number of inequalities on the same Cartesian plane. That region is what we call feasible region. And that region satisfies all the given inequalities. Even we so when we are coming to look for points or optimal points, that can help us to find the maximum value and the minimum value is where we get them from. We never pick a point outside the feasible region. And even the reason as to why even we don't, maybe as we are going to see in the next part of this video, when it comes to reading, you don't read a point on a dotted line. We only read points on a solid line. Even if even if two lines, one is dotted and another one is solid, the moment they intersect still, we don't read that point at the point of intersection for a solid line and a dotted line. Also, you need to label your axes. If you have defined your variables to be, maybe let x be the number of trips made by the lorry, and then y be the number of trips made by the pickup, please you put what is in the x-axis, that trips made by the lorry, and then trips made by the pickup on the vertical axis. So this is what all about label your axis. Then also you have to show the scale. For all graphs, make sure that a scale is very important. And then also show the feasible region. You can just put there any letter. Maybe it can be R, can be maybe K, and then you say that that is feasible region. And we have our example 1, and it reads that in the settlement, a woman-led tailoring unit was established to empower residents and support the community economically. The unit produces two main types of garments: change shirts, garment A, and school uniforms, garment B. Each change shirt requires 3 meters of fabric, while each school uniform requires 2.5 meters of fabric. The unit is supplied with 600 meters of fabric daily. Due to production limits and agreements with the suppliers, the unit is required to produce not more than 100 change shirts and not less than 80 school uniforms each day. They make a profit of Uganda shillings 80 from each change shirt and Uganda shillings of 60 from each school uniform. The tailoring supervisor, Ms. Kamohan, requested help from the settlement's finance team determine how best to allocate the fabric daily to maximize profit from their operations. And then task: write all the inequalities to represent the tailoring constraints. Then determine how many garments of each type should be produced daily to maximize the profits. Then here we have decided to break it down. Now here we are going to write the inequalities. Then after later we will show the feasible region on the Cartesian plane. And then we determine how many garments of each type that should be produced daily to maximize the profits. Now when you read this, whenever you read the linear programming item, you have to read the problem and identify what is being asked. And if we check what is being asked, it is here. Determine how many garments of each type should be produced daily to maximize the profit. Already you have seen that now they need the school uniforms and even exchange shirts. Because those are the two things they are asking us in the question. Then choose the decision variables. And I would request that you maintain the order as it is given in the question, if possible. Because I'm seeing here exchange shirts being brought first, and even school uniforms brought second. So here we shall come and we say that let the number of garment A and garment B be X and Y respectively. But remember, garment A, those are exchange shirts, and then garment B, school uniforms. So we are going to, after defining your variables, better you come and write the inequalities. First of all, here they are saying that due to production limits and agreements with the suppliers, the unit is required to produce not more than 100 exchange shirts and not less than 80 school uniforms. And here you need to ask yourself, the moment they say not more than 100 exchange shirts, which variable has represented exchange shirts? That is x. Then we shall come and we say that x is less than or equal to 100, not more than. So that is the maximum. So that is 100 and below. Then here, not less than 80 school uniforms each day, not less than 80 school uniforms. So that is, those will be 80 uniforms and above. So to be y is greater than or equal to 80. Then for the material, here we have the exchange shirt requires 3 meters of fabric, and then each school uniform requires 2.5 meters of fabric. And then here the available material is 600 meters of fabric. So here we shall come and we say how much material will exchange shirts take? How much does each? Here each exchange shirt requires 3, and how many are they? They are x. So we shall have 3x. Then here, how much material does each school uniform take? 2.5. Then times the number of school uniforms, that is y. Then is less or equal to 600. Please, you cannot make uniform from the material which is not available. You can either use the whole of this material of 600 meters and below. So you can see that in this, for this condition, they're not giving us even the statement that can easily open our eyes to use an inequality symbol. So here we shall have x plus 2.5y is less than or equal to 600. Then we have also non-zero constraints because we cannot produce negative school uniforms and negative shirts. You may not produce, that is 0, and even all you produce from that is greater than 0, all 1 and above. Then after writing inequalities, it's better also you write the objective function. What is the aim? What were they intending to? Here they are saying to maximize the profit. But remember, on every exchange shirt, he gets the profit of 80 Uganda shillings. And then every school uniform, he gets, on each school uniform, he gets 60. So here our objective function will be 80x then plus 60y. Then also proceed and write the equations. You just replace the inequality symbols with equal signs. And you can see where I had x is less than or equal to 100. I have I have x is equal to 100, y is equal to 80, then 3x plus 2.5y is equal to 600. But the moment you see this, then you just know that 2.5 is same as 5 out of 2. So 3x plus 5 out of 2y is equal to 600. You multiply 2 throughout, because it's the one I have as my denominator. 3 by 2, I get 6x. Then 5 out of 2 times 2, I get 5y. And then is equal to 600 times 2, I get 1200. And then we have x is equal to 0 and y is equal to 0. Then after writing the table of coordinates, then after writing the equations, it's better also you write that you come up with the table of coordinates. May I always encourage students to use the intercepts. The intercepts save time. So assume for this equation for 6x plus 5y is equal to 1200. This is my table. When x is 0, assume I have here x. So 6 times 0, that is 0. Then I'll remain with 5y is equal to 1200. You divide 5 on both sides. 1200 divided by 5, I'll get by 5, I'll get 240. Then when y is 0, now 5 times y, I'll get 0. Then 6x is equal to 1200. Then I'll come and I say that divided by 6, divided by 6. 6x divided by 6, I get x. Then 1200 divided by 6, I get 200. So here we shall have 200 as x when y is 0. Then also here when x is 150, then I'll come and say 60 times 150, that is 900. Subtract it from 1200 and we shall get 300. So 300 divided by 5, I get 60. So this is the table. Then after, I'll come and I write the coordinates down. Here we shall have 0, 240, then 200, 0, 150, and then 60. After drawing the table of coordinates, better you go and now show the inequalities on the Cartesian. And then now, we are going now to the graphing part. Of course, now let's graph those different inequalities. First of all, you have to write a simple title, a graph showing feasible region. Then the scale is very important. 1 centimeter represents 20 school uniforms, and you can see school uniforms is on the vertical axis. Then also here, horizontal scale, 1 centimeter represents 20 change shirts, and you can see that I have them here. Then after that, you need also to come and label your axes. What is on the x-axis? Change shirts. What is on the y-axis? School shirts. Then later, show those inequalities on the Cartesian plane. First of all, you can see that here y is greater than or equal to 80. So I'm going to draw my line y is equal to 80. Then I ask myself, where is y greater than 80? It is above, because I can see this is above 80 and then this is less. And me, I shade the unwanted region. So I'll shade this down part, the less. I always shade the opposite. If it is greater, then I shade less, because that is the unwanted region. Then also here, x is less than 100. So if you draw the line passing through 100 along the x-axis, so this is my line. Then come, where are the integers less than 100? Here on the left. Then integers on the right are greater. So shade the greater part because that's the unwanted region. Then let's finalize with this 6x plus 5y then is equal to 1200. So here we shall have the coordinates are 0, 240. I have them. They are here. I have also 0, 200, 0. So also I have them here. So after you join these points using a straight line, then also you have to make sure that you label your axes, you label your equations very well. Never bring back your inequality symbols on the Cartesian plane. Never. Don't bring them. Just keep them here when you are writing them. At the same time when you are testing. And when we are testing, take an example. We can use 0, 0. I will come and I say that 6 times 0, I get 0. Then plus 2.5 times 0, still I get 0. Is 0 less than 600? Yes. It means that this region below the line satisfies the inequality. So I'll shade the upper part. So this is all about the feasible region. And then R, I've labeled it here as the feasible region. Then after that, you'll need again to come and check determine how many garments of each type should be produced daily to maximize the profits. Remember, our objective function is here. That is, profit is equal to 80x plus 60y. So here we shall have our table format as points, then xy, and then profit, the objective function. So read those values from the feasible region. Here you can see that I have 180, you can see it here. Also I have 100 and 120, also I have it there. And then I have also other points like 60 and then 160. 60 and 160. It's around there. Then here we have 60 and then 160. Then I have 80 and 140 also still in the region. So this is the feasible region. Now use those points and make sure that when you are looking for a point that will give you the maximum value, you have to pick a point which is very far from the origin, especially at the point of intersection for different lines or the vertices. So here we can read this one, this one, this one, and this one. But also you don't fail to read also other points as long as they are within the region. So I have 100 and 120, then 100 and then 80, 60 and 160, then 80 and 140. So when it came to substituting, I see this one which is highlighted with a yellow color. Is the one that gives us the maximum value. And remember, it is the one intersecting at 100 and 120. So we shall say that the point is 100 and 120. So 100 change shirts and 120 school uniform should be produced daily to maximize the profit. Item 2 reads that Patricia, a farmer who is to buy up to 25 cows altogether for a new herd, she can buy brown cows at 500,000 shillings each and black cows for 800,000 shillings each. Then she can spend a total of not more than 16 millions. She must buy at least 9 cows of each type. On selling the cow, she makes a profit of 500,000 shillings on each brown cow and 600,000 shillings on each black cow. Ask, Write down all inequalities to represent the above conditions or constraints. Then here now we have our part A. Now that is, here we are saying we are going to extract the inequalities to represent the above conditions. Number one, what are you going to let? Here we are in the question they have been asking us to find the number of cows of each type, of each color type that Patricia can buy to maximize the profit. And now here we are going to let the number of brown cows be X and number of black cows be Y. Defining your variables, as remember, it is our first step. So let the number of brown cows and black cows be X and Y respectively. So here they are saying that who is to buy up to 25 cows altogether. It means that the total number of cows shouldn't go beyond 25. And here we shall have brown cows plus black cows is less or equal to 25. And this is my inequality. Then also here, one brown cow is sold at 500,000 shillings and black cow is sold at 800,000 shillings. So together, the amount of money spent on brown cows, I'll get 500,000 X plus 800,000 Y is less or equal to 16 millions. This 500,000 X is spent on brown cows, and then this 500,000 X is spent on brown cows, and then 800,000 X is spent on black cows. And why are we using less or equal to? Because the available money to purchase cows is 16 million. So you cannot spend what you don't have. That's why I'm using less. Either use the whole of 16 millions or less. So that's why you are seeing us having less or equal to. Then also here, she must buy at least 9 cows of each type. That's why you are seeing us at least is same as greater than or equal to. X is greater than or equal to 9, Y is greater than or equal to 9. And here our equations. And then this is our objective function. And remember here on selling the cattle, she makes a profit of 500,000 shillings on each brown cow and 600,000 shillings on each black cow. So to get the profit, you need to know how many brown cows I must buy and how many black cows that I need to buy. So our objective function will be 500,000 X to get the amount, the profit that we will get from brown cows, then 600,000 X, 600,000 Y, the profit that you'll earn from the black cows. So this is our objective function. And then after that, also table of coordinates is very important. So we have two lines. We have x plus y is equal to 25. And may I use the intercept formula. And here we shall have 3, I have x and y. So it means that when x is 0, when this x is 0, then y is equal to 25. Because 0 plus y, I get y. Then y is equal to 25. So the coordinates will be 0, 25. Then when also y is 0, then our x is 25. And then our coordinates will be 25, 0. Then also I have the second line, and that is 5x plus 8y is equal to 160. Where does this equation come from? I have reduced this. 500,000 x plus 800,000 y is less or equal to 16 million. And may I divided by 100,000 throughout. Here, by 100,000 I get 5. Here, 800,000 divided by 100,000 I get 8. then 16 millions divided by 100,000, I get 160. So when x is 0, y is equal to 20, and the coordinates are 0, 20. When y is 0, x is 32. And then here when x is 16, y is equal to 10. And here the coordinates are 0, 20, 32, 0, and then 16, 20. Then after that, you come and also graph. So here a graph showing feasible region. Then the scale, 1 centimeter represents 2 black cows on the vertical axis. You can see. Even 1 centimeter represents 2 brown cows on a horizontal axis. You can see. Now I have labeled my axes very well. Make sure that you label your axes. What is on the x-axis? Brown cows. What is on the y-axis? Then I have black cows. Then after doing that also, you come and show all those inequalities on the graph, on the Cartesian plane. X is greater than or equal to 9. And if this is the line, x is equal to 9. Now, where are the integers greater than 9? Those are the integers on the right. So we are going to shade the opposite now. The integers which are less than 9 on the x-axis. So I have 6, I have 8, I have 4. So I'm going to shade this side. So here we shall say I'm going to shade this side which does not satisfy the inequality, and that's what we call the unwanted region. So I shade. And remember, because of greater than or equal to, less than, greater than or equal to, greater than or equal to, less than or equal to, even less than or equal to, that's why all my lines are bold. So for the case of greater than or equal to, or less than or equal to, our lines must be bold, as we explained earlier. So even here you're going to see that y is equal to 9. These lines disturb most students. For you, whenever you hear that line y is equal to maybe 9, for you want that line to be same as y-axis. But it's all about drawing a line, passing it through 9 along the y-axis. And this is my line here. So y is equal to 9. And where the integers greater than 9? Above. So I'm going to shade below. Then also here we have line x plus y is equal to 25. And my friend, these are the points. 0, 25, 0, 25. I have it here. And also here 25, 0. Those are the points. And then here we have, then I've drawn it. Then you join the 2 points with a straight line using a ruler. And make sure that you draw this graph using a pencil. Then after that, also label your lines as equations, not inequalities. Never bring back the inequalities here, inequality symbols on the Cartesian plane. Let them stop there when you're writing them and even testing. But on the Cartesian plane, you shouldn't see any inequality symbol appearing there. Then also we have this second line, we have 0, 20. It is here. And also we have 32, 0. It is also there. So those are the two lines. When it comes to shading, here we shall come and we say that we always, students are encouraged to use, in most cases, 0, 0 as the testing point. I come here and I say that x plus y is less than or equal to 25. Let me drop this, maybe like less equal to. So 0 plus 0 is less than 25. True? Yes. 0 is less than 25. So we shall not shade this region of the origin. So I'm going to shade above. Also here, for the case of this inequality, still, I'll come and I say that 5 times 500,000 x, 500,000 times 0 is 0. Even here times 0 y, it is 0. And I'm asking, is 0 less than 16 millions? Yes. So I'll come here and I say that this region here satisfies the inequality, so I will shade the upper part. And in most cases, the upper part is greater than the lower part. So that's how, but it's better you test, either picking a point below or above. The moment the point above that you have picked does not satisfy the inequality, then just know that you are going to shade up. So don't pick 2 points. You pick one above and then you pick one below. And again, you use them to test. Just use 1 point. It means that if 1 point satisfies, then it means that a point on the other side won't satisfy. So we shade that region that does not satisfy the inequality. Then this is my feasible region. This region satisfies all inequalities. And make sure that also you go for like the point of intersection. These are the vertices, the corners. We have this corner, we have this corner, we have this corner, and even we have this corner. But whenever we are looking for maximum, a point that can give us maximum value is the point which is very far from the origin. But now you cannot take this point here, like 9, 9. This one will just give us the minimum value because it is very close to the origin. Always pick a point which is far from the origin, and in most cases, pick a point maybe from like at the point of intersection for these lines, or very close if at all. You cannot treat that point. This is where we shall expect our point that can give us the maximum value. Then part B says, establish how many of each color type she must buy for obtaining the maximum profit. Now, the point that we are going to use will be read from this feasible region, this region that remains unshaded. So here we'll need to come and we extract our table. Remember, our objective function is 500,000 x plus 600,000 y. Now this is the point, this is the format of the table. Points x, y, then here x and then y, then this is our objective function. So we shall come and read. May I have 15, 16, 9, then I have 14, 10, I have 14, 11, and then I have 13 and 11. So better substitute like the way we have done in item 1, and then complete that table yourself. Thank you so much for watching. If you've not subscribed, make sure that you subscribe, like, and share. See you in the next video.